In this session, we're going to discuss Newton's method. Newton's method for solving equation is another numerical method for solving an equation f at x equal to 0, or we're looking for the root of our equation. It is based on geometry of curve using the tangent line to a curve. As such, it requires calculus, in particular differentiation. So the idea of Newton's method, okay, so is basically we're going to determine this dot on this curve or in this equation. Okay, so we start with an initial guess x sub 1. Okay, we calculate the function at x sub 1. If x sub 1 is equal to 0, we are very lucky and have a solution. So we already know the root of our variable, of our equation. Okay, but most likely f at x sub 1 is not 0. So let f at x sub 1 is equal to y sub 1 as shown in this figure. Okay, so we now try for a better guess. So how to find a better guess? So the trick of Newton's method is to draw a tangent line, okay, to the graph y equal to f at x at the point x1, y1. So this is how we do it. Okay, so we have x sub 1, we have y sub 1 based on the formula, and then from there, we're going to draw a tangent line until it intersect the x-axis. Okay, so this tangent line is a good linear approximation to f at x near x sub 1. So if it's 0, we're finished. Okay, if not, then we draw the tangent line to yf at x to at x sub 2, y sub 2, and our next guess will be x sub 3. Okay, so this will be the new solution. Okay, so as you can see here on this figure, so x sub 1, x sub 2, x sub 3 rapidly approach the red solution point. Okay, continuing in this way, we find points x sub 1, x sub 2, x sub 3, x sub 4, approximating a solution. This method for finding a solution is the Newton's method. So drawing a tangent line and then until we get to this red dot, which is the root. Okay, so what is the formula for Newton's method? So definitely we don't want to draw lines, okay, and determine what is the area, what is the length of the different side of the triangle to determine what is the location of this red dot. Okay, so let's review your algebra. Okay, so we're going to use x-intercept. Okay, so yung x-intercept concept. So find this x-intercept. Okay, so the tangent line we are looking for passes through the point x sub 1, y sub 1. Okay, and as a gradient of first derivative of x sub 1, first derivative of the function of x sub 1 rather. Okay, recall that given the gradient m of a line and the point x sub 0 and y sub 0 on it, the line has equation y minus y sub 0 all over x minus x sub 0 equal to m. Or equivalently, y is equal to m times x minus x sub 0 plus y sub 0. So I hope you still remember this formula. This is the basis of Newton's method. Okay. But in our situation, it's not y sub 0 is the basis, but the y sub 1 and the x sub 1. This will be your y sub 0 and x sub 0 based on this formula. So y sub 1, x sub 1, and we're looking for the new x and the y. Okay? So based on this, okay, based on this graph, this is how we determine y minus y sub 1, x minus x sub 1. Okay? And now we all know that we are looking for the root. So we're going to set y equal to 0. Okay? So therefore, our new formula will be, or the formula for x-intercept will be x equal to x sub 1 minus y sub 1 all over first derivative of the function x sub 1 at x sub 1. And we all know that y1 is the result of function at x sub 1. So therefore, our formula is x sub 1 minus function at x sub 1 all over first derivative of the function at x sub 1. Okay? So this is our formula for Newton's method. Okay? So what will be the algorithm? So definitely we're going to determine first, what to determine first? The first value of your x, your guessed, whatever the value will be, kahit ano yan, okay lang. And then we have the first derivative. You need to, what do you call this? You need to remember the first derivative of a certain equation, how we're going to derive it, because that will be the denominator of our formula. Okay, so kindly review. Okay, so we know your x sub 1, the first value, the guess value, substitute to the formula, to the function. So we have our numerator, substitute x sub 1 to our first derivative function of the function. So we have our denominator. Evaluate this, you have your x sub 2. Then if the error is not met or is not less than the desired error, so we're going to continue our solution. Now the basis will be x sub 2 to get the next x, which is the x sub 3. Okay, so same formula but different values. Okay, until we get the desired root. Okay, so that's the algorithm for Newton's method. Okay, so just remember this formula. X sub n plus 1 is equal to x sub n equal to function at x sub n all over the first derivative of the function at x sub n. Okay, so let's have an example. Okay, so let's answer this. So we have x cubed plus 5x minus 5 is equal to 0. Okay, so before we guess or before we give a value of x, we need to get first the first derivative of this equation. So x cubed plus 5x minus 5 is first derivative is equal to 3x squared plus 5. Am I right? So this will be our formula for our denominator. Okay, so my guess will be 0. Okay, so 0, substitute here, 0 minus 0 plus 5 times 0 minus 5 all over, okay, so 3 times 0 squared plus 5. So that will be our first solution. So 0 minus negative 5 all over 5. So the answer is 1. So next will be, we're going to substitute 1 to our next loop. So it will be 1 minus 1 cubed plus 5 times 1 minus 5 all over 3 times 1 raised to 2 plus 5. Okay, so that will be our solution for the next iteration. So the result is 0.875. Then let's continue it. So yung bago nating x is 0.875, substitute to our equation, to our working equation. So the result is 0.8688 and the error is 0.71%. But don't forget 0.01% is our desired error here. So let's continue. So on the next and the fourth, it's less than 1%. So therefore, this is our result. Okay. So as you can see here, it's fast to get the root. Okay. The only problem here is how to determine the first derivative of the function. But if you know how to get it, just use this formula, you could get the root of the equation. Okay, another example. We have x cubed plus x minus 2. So let's get first the derivative of this. So first derivative is 3x squared plus 1. Am I right? Okay. So now, I'm going to guess the root is 0. So substitute to our equation. 0 minus 0 cubed plus 0 minus 2 all over 3 times 0 squared plus 1. So the answer will be 2. Tama? Kasi 0 minus negative 2 all over 1, which is 2. Then 2, substitute to our working equation. So 2 minus 2 cubed plus 2 minus 2 all over, okay, 3, 2 squared, 3 times 2 squared plus 1. So the result is 0.138. Then substitute it again to our equation. So we have a new x, 1.08. Then substitute it again to our working equation. We have 1.004. And again, our error should be less than or equal to 0.01%. So let's continue our solution. So 1.001 is 0.48, not yet acceptable. So substitute again to 1.001 to our working equation. We have 0.00. So the result is 1. Okay, so we stop here. So tama naman to kasi 1 cube plus x, 1 cube plus 1 minus 2 is 0. So that will be the root. Okay, so that's how easy Newton's method. Okay, using this formula, get the first derivative, guess the value of x, substitute to our equation, then repeat it until we get the desired error. Okay, so if you have any question about Newton's method, so kindly send me a message. Thank you.